Hello and welcome to AWS Innovate 2017. This presentation, Active Directory on AWS, will provide you with information on options and best practices to help you get started today with setting up Microsoft Active Directory on AWS. My name is Steve Shirkey. I'm a solutions architect for Amazon Web Services covering the ASEAN region, and I will be presenting this session to you. So let's get started. During this session, we're going to cover a few things. First, we're going to talk about why we care about running Active Directory in the cloud. Next, we're going to talk about the three most popular ways of delivering Active Directory services on AWS. After that, we will drill down on AWS Directory Service for Microsoft AD Enterprise Edition, also referred to as AWS Microsoft AD. Finally, we will drill down on other Active Directory options, such as running AD on Amazon Elastic Compute Cloud, or EC2 instances, running our AD connector service, and so on. First, why do we care about Active Directory in the cloud? Well, from our on-premise experience, Active Directory provides great benefits for end users. Users can sign in with user IDs and passwords, or even certificates, giving them a single sign-on experience from their desktops to access corporate applications. Active Directory also gives corporate applications the ability to utilize Kerberos tickets that were issued to the clients, which the application can then use to verify who the user is. The application can also identify which groups that the user belongs to, and then perform access control based on that group membership, making administration of the application more convenient. Active Directory also has the concept of group policy baked in, giving administrators the ability to apply different policy for the users and the computers that are members of the domain. With group policy, you can apply specific scripts or machine configurations at login and logoff, and group policy can be applied to specific organizational units so that you can set permissions to all members of the domain or apply policy at lower levels of the hierarchy, and those policies will then be inherited by all child members of that hierarchy. This gives you a convenient means of applying policy to large numbers of users and computers. And finally, while we believe that over time our customers will be moving all of their workloads to the cloud, we are also committed to ways that make AWS an extension of your on-premise environment, leveraging a hybrid configuration. And AD in the cloud is a key component of making that easier to do so that you can extend your current infrastructure to the cloud and provide users with the exact same experience and benefits when running your Microsoft workloads in the cloud. In addition, even if you are not running your Windows workloads with Active Directory today, you can be in a situation in the future where you are spinning up hundreds or thousands of Windows instances in the cloud, and you can have a consistent method of managing those instances, and Active Directory can provide that to you. So customers really have three choices of how to integrate Active Directory into their Windows workloads on AWS. First, AWS offers a managed Active Directory solution using AWS Microsoft AD. This is a completely managed service with monitoring, patching, and snapshots handled automatically by AWS. Second, a customer can run and manage an Active Directory server on an EC2 instance, either replicating directory data from their on-premise environment or establishing a trusted domain. Finally, a customer can simply domain join their EC2 instances running Windows to their existing on-premise environment. We will be looking at all three of these options available to you, and we will contrast the trade-offs between these approaches so that you can choose the one that's most appropriate to your use case. The first option we will look at is running an AD environment in your on-premise network and joining EC2 instances to your on-premise domain. On the left side of this diagram, you can see domain controllers sitting on-premise in your computer network, and the workstations and computers in your environment are domain joined to that domain so that they are doing authentication and authorization to those domain controllers. In this situation, you create a connection between your on-premise environment and your Amazon Virtual Private Cloud, or VPC. This connection can be created via a standard IPsec VPN connection over your existing internet connection, or using an AWS Direct Connect dedicated connection. With your connection established and appropriate routing configured between the two environments, you can now stand up any EC2 Windows workload, such as Microsoft IIS Web Server, a Microsoft SQL Server, or in .NET applications that require Active Directory access. And following best practices, those servers can be run redundantly across availability zones so that you have a highly available, scalable solution. And in order to provide that necessary Active Directory integration, those servers are domain joined to the remote domain controllers on the on-premise network. Now when you have users in your on-premise network that need access to the applications that are running in the cloud, the blue line is where those application queries are made to those applications hosted in your VPC. The applications are then able to get the Kerberos ticket from the client, which allows those applications to verify the users because they are joined to the same domain. And those validated users and group memberships can authorize access to application resources. Now, the risk of this approach is that all communications for domain authentication and authorization occur across these links. This could lead to extra latency and performance penalties from any application communications between member servers in the VPC and on-premise domain controllers. In addition, if the links between your on-premise environment and AWS are ever lost, no authentication will be possible on those AWS applications. The next option for Active Directory on AWS is to stand up AD on EC2 Windows instances in your VPC. This diagram shows how you can extend your on-premise environment by establishing a trust to a completely new domain hosted in your VPC on AWS, or even replicating directory information between your existing corporate domain and a new domain controller. By choosing this option, you gain some flexibility and performance improvements, as well as isolate the type and amount of directory traffic passing between AWS and your on-premise network. But you will also incur additional administrative overhead of managing an additional domain and its domain controllers as Windows instances on EC2. The third option is that you could use our AWS Microsoft AD service. With this option, the configuration is similar to the previous option, except that the service is fully managed by AWS, and no replication is possible between the on-premise directory and the directory in AWS. With AWS Microsoft AD, we provide the management of the Active Directory domain controllers, while you can still administer the domain yourselves. The model that supports this is a trust model, requiring that authentication of users to the on-premise domain occur as part of a trust extended between AD forests. The same behavior that existed in the previous scenario exists in this scenario as well. The additional benefits include the use of some AWS services, such as Amazon Relational Database Services, or RDS, for SQL Server, where those servers can now be joined to the domain, and authentication and authorization of those on-premise domain users can be performed at the database engine itself. One additional scenario is to leverage AWS Microsoft AD as a standalone directory service separate from your on-premise domain. You could then leverage virtual desktops such as Amazon Workspaces to provide a desktop environment in the cloud, and then access those workspaces using internet-connected devices, and have all of your applications accessible within the cloud. If a trust is established between AWS Microsoft AD and the on-premise network, end users are authenticated in the corporate data center, as shown by the yellow line. Application traffic, shown by the blue line, then goes into the cloud. Applications within the private subnet can use the Kerberos tickets to authorize users by communicating with the domain controller in the cloud. The Kerberos ticket trust is managed through trust communications shown by the green line. This model minimizes traffic initiated from your VPC to your corporate environment by narrowing it to trust communications. This can be controlled by firewall policies to the statically addressed Microsoft Active Directory domain controllers. Now let's talk about different Active Directory options and what the trade-offs are. First, let's look at operations management in the top row, starting with the on-premise AD on the right. In this scenario, you're managing everything. You manage the hardware, you manage the configuration, you manage the high availability, you are doing all of the work. When running EC2 AD instances shown in the middle column, you are managing Active Directory, you manage the configuration, and all of the domain administration activities. But you no longer have to worry about the underlying hardware of those domain controller instances, since now you are doing that in AWS, and you can scale that up or down as your needs change. In the case of AWS Microsoft AD on the left, everything is managed by AWS. We provide a way of turning it on, we create the domain and configure the domain controllers, so this saves you a lot of effort in the area of operations management. Let's look at availability across the three options. With the on-premise Active Directory solution, you have to manage the availability strategy, possibly via redundant data centers to provide fault isolation, and this effort is much more difficult compared to hosting on the AWS environment. For availability of the EC2 AD instance options within AWS, you can create Windows EC2 instances across multiple availability zones in a single region, isolating your domain against faults, while your domain controllers can replicate directory information across low latency links between availability zones. For availability of the AWS Microsoft AD option, all of this is handled for you, with the domain controllers automatically created across availability zones during provisioning. Now let's consider other options from a networking standpoint. If you're using an on-premise Active Directory domain, you have several ports that must be opened up to permit the necessary AD and LDAP interactions between your VPC and the on-premise controllers. Of course, this means that there are many implications from a corporate security and firewall administration standpoint that will need to be managed. If you're looking at AD on EC2 instances, then you have the ability to extend a trust or even replicate your directory. And so you can now limit most of your activity between your VPC and your on-premise directories to just those EC2-based domain controllers. The remaining applications in your VPC can communicate to these cloud-based domain controllers, not traverse into your corporate network. Further, if you choose a trust model instead of a replication model, less ports are required and less surface area on your on-premise domains is exposed to the AWS environment. The same applies for the remaining option, the AWS Microsoft AD option, where you only have a trust model for extending your on-premise environment to your VPC environment on AWS, which is the least exposed model in terms of communications flow between the two environments. Finally, for administrative control of your domains, if you're hosting your AD on-premise, you have full control of that environment. The same applies to the EC2 AD instances, which give you equivalent amount of control as your on-premise implementation. With Microsoft AD, since this is a managed service where you have an extended administrative rights, the approach we took was to create an organizational unit in the directory, which we then delegated administrative rights to that OU. This provides most of what you will need, but there are some constraints, and we will discuss those in the following slide, where we will talk about what is the most appropriate choice for your needs. So how do you decide what is the most appropriate option? Well, the decision to use EC2 AD instances is primarily driven by two issues. While trust can be very effective, customers may have the requirement for a replicated Active Directory solution across multiple regions. Because AWS Microsoft AD cannot be part of an on-premise forest, EC2 Active Directory instances are required for a cloud-based AD solution in this case. AWS Microsoft AD does not currently delegate the key permissions required to support some applications. This would include applications requiring schema extension, special service accounts, or access to containers outside the delegated OU. Before making a decision, it's a good idea to have a complete list of applications that you want to run in the cloud and conduct a review of permissions required versus permissions that are granted in AWS Microsoft AD. If you're considering the Active Directory on-premise model, it is a good idea to understand how link latency may affect application performance. This is because any Kerberos authorized traffic from services in the cloud must communicate through the link to your on-premise environment. This increases the round-trip delays in processing application requests. It is also important to understand the security implications of opening up your corporate network for access by cloud applications for authentication and authorization. Finally, if you are considering AWS Microsoft AD, consider the benefits and constraints that the solution brings. The service works out of the box, requires no systems administration of underlying Active Directory domain controllers, and operates at a minimal cost compared to EC2 AD instance options. It provides the ability to integrate with both SQL Server running within AWS RDS service, as well as supports AWS enterprise applications such as Amazon Workspaces, and easy integration with Windows instances running on EC2. Just recently, we also announced support for Microsoft SharePoint Single Sign-On and SQL Server Always-On availability groups as well. However, more sophisticated requirements, such as changing domain group policy and those applications requiring additional permissions to modify Active Directory, such as Exchange Server, will not be possible to join into the domain and may preclude this option. Also, there is no Win support with AWS Microsoft AD, so you would need to run one of the other options if that is a business requirement. So let's take a look at the AWS Directory Service for Microsoft Active Directory Enterprise Edition, also known as AWS Microsoft AD offering. AWS Microsoft AD is a Windows Server 2012 R2 Enterprise Edition Active Directory that runs on 2 instances in 2 availability zones. Because it is a genuine Active Directory, it is the best solution for customers who are looking specifically for Active Directory compatibility. To simplify EC2 deployment with AWS Microsoft AD, EC2 includes seamless domain join functionality when launching new EC2 instances. For customers who have existing on-premise Active Directory, AWS Microsoft AD can also be configured with cross-forest trust so that on-premise user accounts can be used by EC2 workloads when authorized access. Another key benefit of AWS Microsoft AD is the integration with Amazon RDS for SQL Server, our managed SQL Server solution where AWS manages, patches, and backs up the SQL Server. Your SQL Server application runs in the cloud and can authenticate AD user accounts that are either contained within your AWS Microsoft AD domain or authenticated via trust between AWS Microsoft AD and your on-premise domain. Let's discuss how a domain trust model works between your on-premise environment and your AWS VPC environment. A one-way trust from AWS Microsoft AD to your on-premise AD allows AWS Microsoft AD to trust the Kerberos tickets for accounts authenticated against your on-premise directory. This allows you to put resource workloads in the cloud close to the directory they use for access control, while allowing on-premise users to access those workloads with their existing accounts. With a two-way trust, resources that the user identifies in AWS Microsoft AD can potentially access resources in your on-premise network, subject to access controls that you manage. Getting started with AWS Microsoft AD service is very easy. First, from the AWS console, you can select Directory Services, define the associated directory service offerings, of which AWS Microsoft AD is only one possible choice. Next, you choose the option to set up directory. The choice of directory type will now be displayed. You will choose the Microsoft AD option and click the associated Create button. Finally, you will configure the information for this Active Directory domain, specifically the directory DNS name. This DNS name should be unique and separate from your existing on-premise directory name. In terms of the limitations of Microsoft AD, first, it does not support LDAP-S. All of the authentication is secured via Kerberos, but if you're looking at LDAP traffic, that is not encrypted by TLS currently. If you have that requirement, that is not there yet. The traffic is isolated within your VPC, so you're not exposing it on the wires. There are a lot of applications that need to be enabled by opening up permissions to Active Directories, but some applications will not currently be enabled to work directly with AWS Microsoft AD. If you require more than 50,000 users, that is not currently possible. If managed service accounts need to be created or access to specific containers of the directory, or if they need to run code on the domain controllers, this kind of application will not be enabled with the AWS Microsoft AD service. To recap, here are some of the benefits of the AWS Microsoft AD solution. This is a completely managed solution provided by AWS. All maintenance, patching, snapshots, and high availability is provided by AWS as part of a turnkey Active Directory solution. All administration of the AD itself can be performed using standard Microsoft tools that you're using today. You are delegated administrative access to a dedicated OU within the Active Directory domain, by which you can create, update, and delete users and groups, join or remove domain member servers, and apply group policy to member users and computers. You're also provided with a free trial of 750 hours with which to test the service before deciding if it is right for you. We can now turn our attention to some details about the remaining Active Directory solutions. As we've discussed, if the AWS Microsoft AD options are not applicable due to sophisticated Active Directory requirements, then customer-managed EC2 domain controllers, either as an extension of the on-premise Active Directory via replication, or as a separate standalone domain supporting a trust relationship to the on-premise domain, is another option. The customer retains management responsibility for the domain and the domain controllers, including the patching, monitoring, snapshots, and high availability architecture of the domain controllers. With this option, AD sites must be defined according to the business requirements to ensure that member servers are directed to the appropriate domain controllers, and site link cost must be configured. Another directory option is the AD connector. AD connector exists as a simple means to provide authentication for Amazon enterprise applications, such as Amazon Workspaces, Amazon WorkDocs, and Amazon WorkMail, using your on-premise Active Directory. The AD connector is a simple proxy mechanism that eases administration but lacks the robust capabilities of the other Active Directory options mentioned previously. And finally, for those customers with use cases that do not require a full-blown Active Directory implementation, we also offer our AWS Directory Services Simple AD service. Simple AD is a Samba-compliant managed service offering basic directory services. The Simple AD service supports joining a member server just like the AWS Microsoft AD service, as well as integration with AWS enterprise applications. But for a more complete Microsoft-compliant implementation that will support production Windows applications and workloads, we do recommend the use of the AWS Managed AD or directory services hosted on EC2 instead of Simple AD. So finally, here are some resources for you to find out additional information about hosting Active Directory on AWS. The links at the top will provide you a starting point for information for Active Directory and Amazon RDS for SQL Server service. Also, since time to deployment is key for our customers, we have several AWS Quick Starts to help customers get on the platform quickly and launch complex Microsoft deployments faster. Quick Starts consist of CloudFormation templates with predefined AWS configurations optimized for each workload. Quick Starts can offer a reference architecture so customers can visualize the components that they need to have running and how they will work together. So if after today you are wanting to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And remember to validate your technical expertise with AWS certification. Finally, do take the time to provide feedback on today's event so that we can improve the event experience for you in the future. With that, I would like to thank you for attending AWS Innovate.